Hello Pre-Calc BC. Today is our second day of complex polar, so we're going to be doing more with cis or cosine plus I sine theta. So now what we are going to talk about is how to find a product and a quotient when we are multiplying and dividing with complex numbers that are already in polar form. Doesn't that sound exciting to you? So let's just do a quick recap of what rectangular versus polar form looks like when we are dealing with complex numbers. So rectangular form, that's your x plus y, yi, or you might have seen it as a plus bi. Whereas complex polar, this is where we have our r cis theta, which stands for r times cosine theta plus I sine theta. Personally, I prefer this notation because it is faster to write. All right, so basically what this is telling us is if you are multiplying two complex polar numbers, that is the same as just multiplying the radii together and then adding the angles. So I'm going to rewrite this as cis theta 1 plus theta 2. And then when you're dividing complex polar, this is just equal to dividing the radii and, oops, that was supposed to be a cis. And this is a cis, it just doesn't look like it. Cis theta 1 minus theta 2. All right, so it's just, I rewrote it in cis notation. All right, perform the given operations, write your final answer in polar form. Okay, polar form meaning we will end with that cis. Okay, so z1 times z2, all we have to do for that is we will multiply the two radii, 6 root 2 times 3, that's 18 root 2. And then, again, this is just cis 273 and cis 58, and then we are adding the angles. So cis 273 plus 58, and when you add those together, you will get 331. And that is your answer. Now, really careful to check that you have a positive radius, which we do, and that your angle must be between 0 and 2 pi or 0 and 360, which it is. So you're all set. All right, for dividing, we are going to do division for our radii and subtract for our angles. So z1 over z2, that would be 6 root 2 over 3, which is just 2 root 2. Cis, and then we're going to go ahead and subtract our angles. So that's 2 root 2 cis, 273 minus 58 is 215. All right, again, this would be the same thing as 2 root 2 cosine 215 minus I sine, or excuse me, plus I sine 215. Okay, those are the same exact thing. All right, so now we are going to do the same thing, but this time we want our final answer in rectangular form, which means we will have to do one more step. Let's multiply first. 4 times 2 is 8. Cis, and we are adding our angles, pi over 3 plus pi over 6. Well, pi over 3 plus pi over 6, this is like 2 pi over 6 plus pi over 6, which is 3 pi over 6, which is pi over 2. This is polar, or complex polar. I want rectangular, so what you are going to have to do now is expand this. 8 cosine pi over 2, I sine pi over 2, and now we'll have to go ahead and do our unit circle. Cosine of pi over 2 is 0. sine of pi over 2 is 1. And then distribute, you'll just get 0 plus 8i. So 8i is our answer. All right, let's try it again. z1 divided by z2. Divide your radii. 4 over 2 is 2. Subtract your angles. All right, so again, this is like 2 pi over 6 minus 1 pi over 6, which is just pi over 6. This is polar form, but we want rectangular. So now we're going to go ahead and expand this. Cosine pi over 6 plus I sine pi over 6. Cosine of pi over 6 is root 3 over 2. Sorry, I spaced out. And sine of pi over 6 is 1/2. And then we'll just distribute, and we'll get root 3 plus I. Cool, so multiplying and dividing in complex polar are not that difficult at all. Okay. So finally, we have something called de Moivre's theorem. De Moivre's theorem is important because it allows us to take a complex number to a power. I mean, because why would you not want to do that? Am I right? De Moivre's theorem says that if you want to do r cis theta to the nth power, you are just going to do r to the nth power. Okay, so basically you give your radius the nth power, and then you are multiplying n and theta together. Okay, so here's what we're doing. We're taking 4 cis 18 degrees and we're raising it to the 5th power. That means we will raise our 4 to the 5th power. Cis, you are multiplying your 18 and your 5. Okay, and I should have read the directions because it does say final answers in rectangular form. So that means when I do 4 to the 5th, I should get 1024. Cis, 18 times 5 is 90. This would be polar form. I want rectangular. So now I will have to go ahead and expand it. Cosine 90 plus I sine 90. And then I will evaluate. Cosine of 90 is 0. Sine of 90 is 1. And then finally just distribute. So 1024i should be our answer. All right, let's try another one. This one is in radians. So this is the same as saying 2 cis pi over 3 to the 4th power. Again, you'll go ahead, take your radius, raise it to the nth power, so 2 to the 4th. Cis, and then you are multiplying the 4 and the pi over 3, which is just 4 pi over 3. Yeah. So that's 16 cis 4 pi over 3, and that again is polar form, but what we want is rectangular form. So we get to expand. And then you need to know your unit circle. So 4 pi over 3, that would be in quadrant 3. It's a little past pi. And cosine of 4 pi over 3 would be a negative 1/2. And that's because my x coordinate is negative when I'm in quadrant 3. And sine of 4 pi over 3 would also be a negative, but this time a root 3 over 2. And then finally I can distribute, and I'll get negative 8 minus 8 root 3i. And what I would recommend is that you put the I with the 8 so it doesn't look like it's underneath the square root. But if you're not going to do that, make sure it's like super separated there. All right, there you go. Okay, 2 more. Number 8 is going to be a little different. But number 7, more of the same. All right, so again, this is just 3 cis 7 pi over 18. We'll do 3 to the 3rd power cis 7 pi over 18 times 3 is 21 pi over 18. And it'll help to reduce that. So 3 cubed is 27. 21 pi over 18 is just, I can divide both those by 3. That's 7 pi over 6. 7 pi over 6 would also be in quadrant 3 because it's a little past pi. Because again, pi would be 6 pi over 6. So 7 pi over 6 is just past that. Again, this is polar form, but the directions ask for rectangular. So now we'll go ahead and expand this. Okay. And cosine of 7 pi over 6 is going to be root 3 over 2, but it will be a negative because I'm in quadrant 3. Sine of 7 pi over 6, again, that's going to be a negative, but a 1/2, and I've got I. And then we can distribute, and it doesn't really simplify very nicely. It's just going to look like this. Oops, I forgot my 27. So minus 27 over 2i. All right, which brings us to our last one, number 8. The main thing that you should notice about this problem is that it's not in polar form. So this is in rectangular form. We cannot use this method that we've used for the last 3 unless this is in polar. So the best strategy is to move this into polar first. So let's practice how to do that. First, negative 3 plus 3i root 3 should be in quadrant 2 because this is your real and this is your imaginary component. So negative, positive. All right, so we are up here. R squared, we know, equals x squared plus y squared. So that's going to be negative 3 squared plus 3 root 3 squared. That's a 9 plus 3 root 3 squared is 27. That's a 36, and so my radius is 6. I also need to find theta. Tangent of theta is y over x, so that's 3 root 3 over negative 3, which that just reduces to negative root 3. Well, let's look at our pi over 6 and our pi over 3 angles again. Pi over 6 is root 3 over 2, 1/2. That's not tangent of root 3. Tangent of pi over 6 would be 1 over root 3 because, again, tangent is y over x. But this guy, tangent is root 3. That's what we're looking for, root 3 over 1. However, it is a negative, which means that theta is not pi over 3. It is negative pi over 3. But wait, there's more. Negative pi over 3 is in quadrant 4. We want to be in quadrant 2. We cannot change our radius. We need to have a positive angle. So we will have to go ahead and add pi in order to get into quadrant 2. And what that will give us is a 2 pi over 3. What we are now able to do is write this problem in complex polar. This was complex rectangular. I want complex polar. So now I have 6 cis 2 pi over 3. And I am taking that whole thing and I am raising it to the 4th power. Okay, so all we've done right now is change this part, this rectangular form, into this polar form. But the reason we're doing that is because you now have the capability of using de Moivre's theorem. So now we will go ahead and say 6 to the 4th cis 2 pi over 3 times 4 is 8 pi over 3. Okay, but again, we have another problem. 8 pi over 3 is more than 2 pi. So we do need to go ahead and convert this. Okay, think about what 2 pi would be. 2 pi would be 6 pi over 3. So I'm just going to subtract that off. And that leaves me with 2 pi over 3 again. Okay, so we have to rewrite this one more time. 6 to the 4th is 1296. I can't leave this as 8 pi over 3. It's not correct notation. We can't have an angle more than 2 pi, so we have to rewrite it as 2 pi over 3. Okay, this is complex polar. All right, so for example, previous problem, this step is equivalent to where we were right here. Now we have to go ahead and convert it to rectangular. Okay, so 1296 cosine 2 pi over 3 plus I sine 2 pi over 3. And you need to know your unit circle. Cosine of 2 pi over 3 is going to be a 1/2, but it is a negative because we're in quadrant 2. Sine of 2 pi over 3 is a √3 over 2. It is positive because y is positive in quadrant 2. And then finally, you can go ahead and distribute. Plus 648I √3. And again, notice I tucked this I next to the √3 in front of it. All right, so there you go. That's de Moivre's theorem. I hope you found it enjoyable. Have a great day.